The world of AI is a vast and deep one, with tremendous potential to do the unthinkable. But while everyone is getting hyped up about generative AI, there's another kind of AI that's mostly overlooked despite the fact that it's used in nearly every sphere of life. In fact, this type of AI was the very thing that laid the foundation for Chat GPT and every other deep learning AI system you see today. Join us in this video as we dive deep into rule-based AI systems, the mother of all AI. So, what is a rule-based AI system? A rule-based AI system is a system that works using a set of rules. These rules are predefined, meaning they're already set before launching the program. All the program or AI system has to do is make decisions based on the predefined rules. Rules in a rule-based system AI are typical of what programmers call if-then statements. Just in case you're not a computer geek and don't know what if-then statements are, these are program language commands that state a condition and then an action that must be followed if the conditions are met. Rule-based AI systems usually feature these kinds of program commands. And just so you know, various sectors of humanity utilize AI or computer systems that feature this technology. Rule-based systems are employed in healthcare, banking, and security. For example, a rule-based expert system called Mycin was developed in the 1970s to help physicians diagnose and treat bacterial infections. Now, I'm sure you're thinking 1970s? Was rule-based AI even conceptualized at that time? Well, yes. You see, the concept of rule-based systems dates back to the 1950s. In fact, some very interesting stuff was done with this technology before machine learning algorithms came into the picture. But before we go into all that, take this moment to hit the like button and subscribe to this channel. It's your little way of supporting us to make more interesting videos like this. Now let's get back to our video. Rule-based systems have been around since the 1950s, and it was the fundamental building block for AI. AI research during these times focused on rule-based systems. But as bigger data became inevitable, there was a need for a new kind of AI that could learn and adapt to new data. This is how machine learning came to be. However, nonetheless, rule-based AI systems were still needed in various scenarios. Up till today, rule-based systems are popular due to their simplicity, accuracy, and speed when processing data. They also provide great flexibility, as developers can easily customize them to suit necessities. The rules in these AI systems are written in human-friendly language. For instance, if X is true, then Y is true. They are predictable and dependable systems that will always produce the same outcome, provided the same conditions are met. The system can also be scaled up or down, depending on the volume of data it's set to handle. Now let's talk about another type of AI system, knowledge-based systems. These types of systems differ from rule-based systems because there are no rules. In fact, just as their name implies, it's all about knowledge or data. Knowledge-based systems use facts that are stored and organized in a database. Certain inferences are drawn from these facts and then decisions are made. In other words, a typical rule-based system will interpret the data in the database, look for patterns and relationships, and do anything it must to make sense of the data and draw a conclusion or make a decision based on the task. Pretty simple, right? Well, not quite. You see, for all these to take place in knowledge-based systems, inference engines must be used. It's quite a complicated process, but thanks to these inference engines, it can all be done in a split second or less. Inference engines are AI tools that make logical deductions from a knowledge database. Such inference engines may be sophisticated expert systems, neural networks, or even rule-based AI systems themselves. So many knowledge-based systems employ machine learning algorithms to facilitate their use and engage their abilities. This is where rule-based systems are king. Their predefined rules make it unnecessary for any second-party program or software. They simply make decisions following the rules set by the programmer. However, knowledge-based systems, on their own part, have the advantage of sophisticated reasoning with no need for coding. One good thing about rule-based AI is that these AI systems don't need training, unlike large language models like Chat GPT. As you know, Chat GPT was trained extensively using data from the internet. About 570 GB of data was used for GPT, including text from Wikipedia, books, articles, and other pieces of writing available on the internet. Large language models like GPT must undergo training to realize their full potential. Remember, it's called machine learning, meaning the machine learns by experience, not necessarily from coding. The training process for LLMs is usually threefold. Again, let's use GPT as the example here. First, it was trained to generate text on its own, then it uses guidance or prompts to generate text, and finally, it incorporates real-time feedback from humans to get better. You'd agree that Chat GPT today is much better and more accurate than 8 months ago. That's because the AI has been learning and improving. But again, all this isn't necessary for rule-based AI systems. Training AI models take time and vast resources. You need tons of high-end GPUs like NVIDIA's H100 that cost $30,000 each. Surely, you can now see why rule-based systems are still pretty much loved by certain organizations and establishments. Not everybody is willing to spend a fortune to get their hands on a new GPT, so they simply develop a rule-based system or RBS and use it. They're easy to create and implement, and maintenance is not an issue too. It's kind of like a plug-and-play AI. And so the big question is, if these systems are so good and versatile, why are machine learning algorithms, LLM, and generative AI still being developed? Well, that's all due to the fact that these other AI systems can go beyond the limits of RBS to learn from mistakes and evolve. Rule-based systems are limited to the present rules, but machine learning systems are not. Let's say, for instance, that you created software that takes 100 different actions based on 100 different rules or if statements. If you desire that software to take more than 100 actions, you'd have to update it yourself. This means you'll have to input the new rules, as many as you feel are necessary. Meanwhile, learning systems will not have to be updated by you. These ones will simply study user data and eventually catch up with the new rules that should be updated. Think of how YouTube learns about your preferred types of videos and begins recommending new videos in that particular niche for you. That's the power of machine learning. Also, generative AI that can generate new content, is all a byproduct of deep learning. So as much as rule-based systems are good for definite outcomes or results based on conditions, machine learning algorithms are ideal for new, unpredictable outcomes. If we are to see the full potential of AI, then it must be allowed to learn and evolve, something that is possible with deep learning. Also, when dealing with rule-based systems, the garbage in, garbage out rule fully comes into play. You automatically get incorrect outcomes or actions if the preset rules or conditions are faulty or incorrect. So, the accuracy of these systems depends on the developer's expertise. Rule-based systems always have an interface where a user communicates with the expert system to find a solution to a problem. These user interfaces are usually simple and employ friendly dialogue. There is also something called an explanation facility. This facility or tool enables the AI system to defend its logic. For instance, if a rule-based medical expert system, or simply put a medical app, diagnoses you as a cancer patient, it should be able to explain why it came to that conclusion. That, right there, can only happen if it has been equipped with an adequate explanation facility. Most sophisticated rule-based AI systems also feature inference engines. But in this case, the inference engines are used to deduce the information the user provides to see if it matches any of the rules stored in the database. Once the information has been interpreted and matched, the process continues from there. This is how rule-based systems have come a long way to become very effective, especially in developing decision-based apps, chatbots, and expert systems for sectors like medicine and surgery. So you see, it all started with simple rules, if-then statements, that aim to generate specific outcomes. But as technology improved, the rules became more and more sophisticated. And now we have some rule-based systems that are so advanced they don't even look like it. From financial analysis to medical diagnosis and natural language processing, there's no sector this AI hasn't served humanity. One fascinating way experts use rule-based systems is by merging or incorporating them into AI systems. When this is done, both AI algorithms complement each other with their strengths, forming a truly powerful software or tool. Rule-based systems have the advantage of being reliable, accurate, and user-friendly. But perhaps their greatest advantage lies in their great potential. The fact that these systems have been around for decades, despite the current surge in machine learning AI, shows their usefulness and potential. And so, it's evident that as AI technology advances, the possibilities of these systems will skyrocket. They'll be highly effective in improving existing systems or creating new ones entirely. Remember to subscribe to our channel if you found this content valuable. We'll see you in the next one.